Okay, 7.1 is all review. It's all about solving systems of equations. I expect you to go into your book and get this filled in. We have equations that intersect. If they're the same line, we have all real or infinite solutions. If they do not intersect, we have no solutions. We have solved systems with substitution, graphing, elimination, and we're going to throw in Gaussian elimination. That's one that's going to be working for us a little bit more in the future sections. I want you to go through the examples, and I want you to have them worked out and shown to me in the class. So on the second page, I want you to go through and do your different methods. But on example number 3, now example number 3 is a tad bit different because it has a square in it. However, the square in it doesn't really change what we do. We're still going to combine them like we would a normal combination. I would change my signs because I want to get rid of y's. When I look up here, x squareds, x's, and y's, what's odd out right now are the y's. So I'm going to multiply by a negative so I can change signs. And now when I combine this, I get a quadratic. This quadratic we solve by setting it equal to 0. And now I can factor. And when I factor, I can solve. When I find my two x values, I do exactly what I do if I found 1. I would plug them back in to one of the originals, and I'm just going to choose the second one because it's smaller, to find the corresponding y's. So if I had 2x minus y is -1, so I'm going to replace the x with -4, and then I'm going to replace it with a 2. So I get -y is -8 added over 7. And -y is 4, so -5 is positive. Now I have two solutions. I have -4, -7, and 2, 5. And if you think about this, this is a parabola, because it's a square. This is a line. I have a parabola intersecting a line in two locations. And that's what we basically found was what those 2 points are. Same thing with example number 4. I want you to work on that. The only difference is what happens is when I combine and I get x squared plus x is -1, so I set it equal to 0, that can't be factored. So you're going to use the quadratic formula on that one. On example number 5, that is a count and value system that you're going to set up. With a count and value system, we're setting up two equations where one equation is based on counting the information and the other one is putting a value on the information. So in this case, when I have $12,000 from two investments, the two investments are A and B, and they added to be $12,000. Then it says I got a value of 9% and 11%, and I got a value of the money at $11.80. Now we have a system that we can go through and solve. I would start by probably moving the decimals over so that I don't have to worry about decimals, and then multiply by either 9 or -9, 11, one of those. All right, on the back page, when we talk about the applications, the best application for a system is in business where we come across this break-even point. This break-even point consists of the initial cost and the cost per unit, and we want to know when the total revenue, the money I make, equals to the total money I spent out. That's called the break-even point. After that, depending on how the graph goes, that tells you if you're making money or losing money, or if it's costing you money to make it, the product, or vice versa. So this break-even point is very critical to any kind of business. So the example that we have here is that we invest $10,000 in equipment. Each unit costs 65 cents, but we sell them for $1.20. So how many items have to be sold before the business breaks even? So when we set this up, we have a cost. The cost has to include everything, the initial plus the per unit. Then we have a revenue. Revenue is just that, exactly what you get for selling the product, 1.2. So if I want to know what is that cost break-even point, I set them equal to one another and I solve. So that's how we practically use this whole systems of equations. Its real purpose is in the business world. How do you find where to make a profit and where do you lose profit, and at what point do you stop because you're no longer making a profit? So that is 7.1.